Greetings everyone. This is lesson 11 of trigonometry for students and surveyors. I'm going to pick up where we left off last time with converting bearings to azimuth, azimuths to bearings. We'll get a little more detail on that. And I know I said we were going to do coordinate geometry and start doing latitude and departure, but I kind of overlooked this important step of it. This has to be kind of mastered first, so we're going to work on this first. Okay, this is more or less the same circle. We'll go through a little bit what we did last time. You have 4 quadrants in bearings. You have the northeast quadrant, southeast, southwest, northwest quadrant. And in bearings, you go from 0 to 90, and then from 90 back to 0 to 90, and then back to 0. And in azimuth, you go from 0 to 90 to 180 to 270 to 360, and you're back at 0. And depends on what kind of, if you're a surveyor, you have a data collector, you'll have it set up to show bearing, or you might have it set up to show azimuth. Civil engineering plans, your property description, your boundaries, those tend to, at least over here in the Pacific Northwest, those tend to go into bearings. And navigation, your compasses, topographic maps, sailing, kayaking, whatever it happens to be, that's going to be more of azimuth. That's going to be where 0 is at the top, and 360 is at the top, and it goes all the way around. To do the math, it's much easier to do it in azimuth, so whatever you set. So now we'll go with conversion. You can easily convert back and forth. One of the things about bearing in people like, or makes it a little simple, is whatever bearing you have to one direction is the exact same bearing minus 180 or plus 180 in the opposite direction. So if you're looking at 45 degrees northeast, you're also looking at 45 degrees southwest. And whatever bearing you happen to have, we'll go 30 degrees southeast is going to be 30 degrees northwest. So that's just how it is. Then you can convert to azimuth. As far as surveying goes, it all depends on how your data collector's set up and if you're doing the math or you're just using the programs. But you're going to end up, you need to be conversant at doing both of these and converting back and forth with ease. Okay, so to convert on this first quadrant, the northeast quadrant, now over here we had a graph the other day with Cartesian coordinates, and they had it broke off into Roman numeral 1 to Roman numeral 3, Roman numeral 4. And they went from 0, Cartesian coordinates go from 0 to 90, we go from 0 down to 90, we go right angles. So if you're in the northeast quadrant, there is no conversion. The northeast quadrant is the same. 60 is 60, 35 is 35, because it just goes to 90 and then goes back down. If you're in the southeast quadrant, everything down here, south here, you're using 180. You could basically, let's just cover these up for now. You're not using these at all to convert. So we just cover those up so you don't get confused. So you're not using those. When you get to the southeast quadrant, you're using 180. And if you convert to azimuth to bearing, it's 180 minus the azimuth. And if you're converting from bearing to azimuth, the opposite, you're converting 180 minus the bearing. And then, so over here I have just a 1/180. So we're going to do an example while we're down here. We're going to go azimuth to bearing. Our azimuth is, remember, 90 goes all the way down to 180. So we're over here, our azimuth is 150. So 150 minus 180 is giving us 30. That's our bearing, is 30. Pretty simple. If you have 30, so this is, remember, this is 90, 80, 70, 60, 50, 30, 20, 10, and 180, and 0. This goes to 0. If you have 30 minus 180, you're going to get 150. So in the southeast quadrant, it's minus and minus. Okay, now we're going to go to the southwest quadrant. It's almost the same. Azimuth to bearing is the azimuth minus 180. And bearing to azimuth is the bearing plus 180. So minus slash plus 180. So let's, we have an example over here. We just look at the blue for now. We'll go azimuth to bearing at minus 180. So our azimuth is 250 degrees. Minus 180 leaves 70. Let's see. Let me just see if that looks right. Enter 180 minus is 70. For some reason it didn't look right, but it's right. And the vice versa, bearing to azimuth. Bearing to azimuth, bearing 70 plus 180. So we go 70 plus 180 and you get 250. So that's pretty simple. Where you might get confused is thinking you need to use 90 or the 90 over here or the 270. You don't. You just can use 180 for the southern hemisphere. This one's the same. Now we'll get over here to the northwest quadrant. And this one is the northwest quadrant. Azimuth to bearing is the azimuth minus 360. And the bearing to the azimuth is the bearing minus 360. So like this quadrant, it's also minus and minus. So let's work one out. Northwest quadrant, azimuth to bearing. So our azimuth is 330. 330 minus 360 is going to give you 30. North 30 west. So, and the opposite's true. North 30 west minus 360 is 330 degrees. That's how you convert. So just remember, this quadrant's the same. This quadrant's minus 180 and minus 180. This quadrant is minus 180 plus 180. You just have to play around if you get confused. And then this one is minus 360 and minus 360 to convert. So that's that. So let's go with that. So now that's important to know. So you can convert, you can get a map and you want to start converting, you want to start adding angles or something. You convert your bearings to azimuth, or you can, obviously do it in the data collector, but we want to teach how to do old school so you can check your work. So you want to use that, or your free 42S on your iPhone or your Samsung. I just talked to a surveyor I knew years ago, and he didn't know about that, and he's really good at his computers and all that stuff and being up on it. He didn't know that, and I showed it to him. We talked about it on the phone, and he immediately downloaded while we were talking. He was like blown away by how cool that is, and especially since they quit making these HP. Hewlett-Packard, you got to start making these HP 35s again, please. We're going to have to get a petition, all of us, going and get them to do that. Okay, so next thing we want to do is we're going to do some angles. We want to figure this is a bearing now, or this is an azimuth. Remember, they're the same on this quadrant. We have 35 and we have 60. Oh no, that's not the one we're doing. This is a different one. This is for over here. Never mind. This is 60 and 30. 60 and 130. I'll show you in a minute how that works. So this is 60 degrees to the northeast, and we have 130 degrees. How do we figure out what that is? Well, that's pretty simple. We just subtract 130 from 60. So 130, 60 minus, and that gives us 70 degrees. And the inverse works true. If you have 60 degrees and you add an angle of 70 degrees, now you're looking at 130. So I'll jump over here to survey talk for a minute. If you're sitting here on a coordinate and your back sight is 60 degrees to the northeast, you'd add this angle of 70 degrees, and that's what your angle would be. And then your data collector is going to automatically calculate that foresight bearing. Your foresight is over here somewhere, is 130 degrees. Then it'll take that slope distance and it'll take that hypotenuse and create a coordinate for it. But that's what we're working ourselves into that, but that's going on there. So you just subtract one from the other as you're going around and get your angle, or vice versa, you add your angle to that. So over here we have 200. Now we're looking at the compass here. And you should, or a protractor, I keep getting those mixed up. You can see that's 200, got my 0 up there, 90, 270. So there's 200 and there's 278. That's pretty easy math. That means that that's 78 degrees. So that's not hard. So you backside, you're backsighting your backside here, you're turning an angle of 78 degrees, and now you're going 278 degrees. So that's basically northwest. Okay, now those are all pretty simple, and vice versa. You subtract to get that. You're gonna get questions on your tests. They're going to give you bearings, and they're not going to be rounded off bearings. They're going to be 278, 31, 47, and 199, 52, 16. You have to convert those, subtract them, convert them back to figure out angle, or vice versa, or add that angle to that to get that. That's all going to be on the test. You're going to have to figure out a lot of bearings and stuff based on angles and distances that you're going to have to backtrack to find those, and then reduce them down to what you need. Now this one's a little different. So we're going from 278. We backsighted this something here, and we've turned an angle up to 30 here, and now we're going 35 degrees. So how do you figure that out? Well, 278 and 35, that's a little different. You can't just 60, 130, or 130, 200, or 200. So because you've gone past the 360, and there's no degree past 360. 360 is the end of it. So how do you do that? So I wrote it down here so I wouldn't blubber around here too much. You want to add. You've got an angle here, and you've got an angle here. One way to do that, when the angle, now this is my symbol, this is our survey symbol. We would write it on our stakes like that. That just means an angle. That's all it means. So when the angle extends past 360, example, 278 and 278 and then 35 degrees. So what do? You go 360. There's a couple ways to do that. 360 minus 78 and then plus 35 equals 117. So let's do that. So we'll go 360, 278 minus is 82, 35 plus is 117. So that gives you this angle here is 117 degrees to there. That's one way, because you got to go up to 360 degrees here, and then you're going to add, and then you're going to add angle. So you need to know what this angle is. Then you add 35 to that. So let me do that again. 278, so I'll just go 360 first. 278 minus, that's 82 degrees between here and the 360. 82 plus 35. And then that's 117. So if you want to know what your angle is between two bearings that cross over 360, that's one way to do it there. Pretty simple if you just think about it. The other way is you could take 278. You're also looking at, here's another angle. Is this angle all the way around here? It would be whatever this angle is minus 360 would give you this. So one way to do that is 278 minus 35. So 278, enter. 35 minus is 243, and 360 minus is 117. Comes up there again. So what I've done is taken this angle. Now this is 278 degrees all the way back to here. So if you're starting at 0, 278 degrees to here. Well, we're not starting at 0, we're starting at 35. So 278 to 35 minus that, and then subtract that from 360, and that's your 117. I know it sounds pretty basic, and I'm belaboring the issue, but that's what I have to do. I just feel like I need to do that. Now, when you're adding an angle to an azimuth past 360, it's similar but not the same. Minus 360 from the sum. So we're going to go 278. Let's just say you're here with your instrument. You're backsighting azimuth 278, And now you're turned an angle over to here to the northeast, and your angle is 117. So let's just see what that does. So 278 is your backside bearing. 117 is your angle. We'll plus that, and that gives you 395. Well, there is no 395 in a circle. It only goes to 360. At least our circles. I think in Europe they use a 400-degree circle. 100, 200, 300, and 400. They do that some places, but we don't. So that's 395, and where was I here? And then 360 minus. So then you add that, then just 360 minus 360 is 35 degrees. So now you're back to 35 right here. So that's what that is. You want to know what your foresight, you've added 117 to the backside, and you're now at 35 degrees. And that is, I think that's all we need to really do on that. We'll go, so you can do that. You have your graph paper, your protractor, and your scale. Practice a few of those and get very, very good at that. Very good, get very practiced at all that. You have every way you can, because what we're going to do next when we do latitude and departure, we're going to be backsiding, adding angles, continuing on, creating new coordinates, starting off with a coordinate and just doing angles like a traverse, adding new angles and new coordinates. And we're also going to do some vertical angles as well. So that will be on the next episode. That next lesson will be 012. And that is going to do it for today, I think. It's a little bit shorter episode, a little shorter lesson today, but please write that down, take a screenshot of it, and practice that, because we're going to be needing that soon. All right. Well, please like and subscribe again. It helps out, and that's all for now.